Substitution versus extension. It would seem that the cleanest way to create an inheritance hierarchy is to take the pure approach. That is, only methods that have been established in the base class are overridden in the derived class, as seen in this diagram. This can be called a pure as-a relationship because the interface of a class establishes what it is. Inheritance guarantees that any derived class will have the interface of the base class and nothing less. If you follow this diagram, derived classes will also have no more than the base class interface. This can be thought of as pure substitution, because derived class objects can be perfectly substituted for the base class, and you never need to know any extra information about the subclasses when you're using them. That is, the base class can receive any message you can send to the derived class because the two have exactly the same interface. All you need to do is upcast from the derived class and never look back to see what exact type of object you're dealing with. Everything is handled through polymorphism. When you see it this way, it seems like a pure as-a relationship is the only sensible way to do things, and any other design indicates muddled thinking and is by definition broken. This too is a trap. As soon as you start thinking this way, you'll turn around and discover that extending the interface, which, unfortunately, the keyword extends seems to encourage, is the perfect solution to a particular problem. This can be termed an is-like-a relationship, because the derived class is like the base class. It has the same fundamental interface, but it has other features that require additional methods to implement. While this is also a useful and sensible approach, depending on the situation, it has a drawback. The extended part of the interface in the derived class is not available from the base class, so once you upcast, you can't call the new methods. If you're not upcasting in this case, it won't bother you, but often you'll get into a situation in which you need to rediscover the exact type of the object so you can access the extended methods of that type. The following section shows how this is done.